Good morning. The bell. March 10th, 2020, Math 1. We're talking about medians, altitudes, angle bisectors, and we're also going to talk about proving triangles congruent today. We're doing 2 lessons in 1. So we're going to do those boxes. Everything today is just identification, some kind of low-level stuff. So let's start with median. Boxes. Yeah, 4 boxes per page. It just keeps it organized. Fuck, I'm stuck. There, I'm unstuck. All right, a median. So I'm going to abbreviate this a little bit or make it a little bit easier. Median is a vertex to the middle. Median, a better marker. Where's my good marker? Median. Oh, it's in my pocket. That's my good one. So median is vertex to middle. So if I draw a triangle, and it doesn't matter, you can do this with any triangle. I pick a triangle, boom, boom, boom. I pick one of the vertices. I've got 3 to choose from. I'm going to choose the top one. And what I'm going to do is I'm going to come down off of that to the middle of this. That's a median. So vertex to middle. That's the median. And to show that I'm in the middle, I'm going to say that, hey, this guy right here is identical to that guy right there. A single hash, single hash. That means, hey, those are the same length. And if they're the same length, it means it's at the midpoint. So median is vertex to middle.
Is it only for triangles?
It's only for triangles.
Okay.
It's only for triangles for us today. You know what, maybe it applies to other things that I don't know about, but we're only going to be dealing with it in terms of triangles. Median, our next one, is an altitude. Before you draw it, I'm going to draw you a cool picture. You're going to like this. Look. What is it so far?
Parallelogram.
Nope, you don't know yet.
To you. That's an H.
No, it's an airplane.
Big.
An
airplane.
Oh, it is. I was close. I said big.
It's an airplane! All right. Why? Because we're about to talk about altitude. If you got an airplane flying over the ground, do they measure the altitude like this?
No.
Like this?
No.
Like this?
Yes.
Yes. An altitude comes straight down to the ground and is perpendicular. So an altitude, in our case, it's vertex to perpendicular. I draw myself a triangle. And I go to a vertex, and I could do this from any vertex. I could do it from this vertex, that vertex. I could do it from any vertex. I'll choose this one though. Boom. It's not necessarily the midpoint. It's not necessarily a median, but it's coming down from a vertex perpendicular, because that's how you would measure an altitude on an aircraft. Altitude.
What's the line in the middle is the altitude?
Yeah, that's the altitude. The red line is the
Isn't
altitude.
that also the vertex?
No, this is the vertex. The vertex, these are vertices.
And the top point is
That's a vertex. That's a vertex. Pick a vertex. I could do it with this one here if I wanted to, I think.
Wait, so then what's the median? The line is the median too?
So the median this is the median. A median is a line that comes from a vertex down to the midpoint.
Okay.
An altitude is a line that comes down from a vertex, any vertex, down to a perpendicular.
Oh, okay.
So this is the altitude.
Thank you.
Chris.
What happens if like your name is like the flat side? Like
So you're not gonna like this, but so if I go, let me make it a little bit more like this. I'm gonna show you all the altitudes. Those are all altitudes. Is that cool?
Yeah.
Now I'm gonna give you another altitude. This one. Ready? That's an easy one right there. That's an altitude right there.
this is
It's coming down off of the vertex to the opposite side. Well, the opposite, it can't get to the opposite side and be perpendicular. And then this guy, so he's got to come out to this one here. I'm not even sure. He's got to hit this side perpendicular. He's got to hit this thing perpendicularly. I don't, here, oh, there it is. There. Don't worry about those. You're not going to see them today. But those are all three of the altitudes for that triangle. This one's a little bit tough because this guy right here, this almost feels like a right angle. So this altitude is actually a side and this altitude is actually a side. So right here, like this, the side itself is the altitude. Does that kind of make sense? I'm beyond the scope of this lesson right with that. Okay, our next one then is it a bisector? Angle bisector. Oh, this is a good one. This is going to be one of your favorites, Presley. The angle bisector. So take an angle. Give yourself an angle. Boop. And make that noise. Boop. 90? Boop. No, that's the wrong noise. Was not the noise. Boop. There you go. Well, you had a little at the end of it.
No, I would do that.
How about this? So you got two noises. You got the outward one. Have we talked about this before? It's kind of a pushing one versus the inhaling one. The
I can do that.
which one do you like better?
The out one.
You like the outward?
I can't do either of them.
Ooh, that's pretty good, man. You hear that? He's got a little beatbox going on over there, don't you? Here, do it again. Come on, man. Come and do it on camera. No? Come on, no. Look, who's absent today? Look, Jackson is never going to be able.
He has
Not
to
to
see
be able
it.
to watch.
He can watch it later, though.
I would make him watch.
Will you do it next tomorrow?
I'll do it
For,
when he's here.
okay, for Jackson. Good.
Okay.
For Jackson. Okay. So a bisector cuts something in half. The idea to bisect, bi being two, right? A bicycle, a biplane has two. A bisector is cutting it into two equal pieces. So here's my bisector. It's taking this angle and it's cutting it into two equal angles. Angle bisector. Is our next one a perpendicular bisector? You're not even playing along at home. Where's your computer? Don't you have your computer in order?
It's in yesterday's class, but it's like the battery thing is broken, so it doesn't charge.
That is very sad.
Like certain chargers don't work.
All right, our last one is a perpendicular bisector, and I'll put that right over here. Come with me. Come over here, Jackson. He's not watching at home. Perpendicular bisector. I think that's my next one. Is it? Perpendicular bisector. So it adds the idea of perpendicular 90-degree angle with a cutting it in half. So I draw a line I am now going to cut that in half with another line that's perpendicular to it. So let's see. You tell me if it looks like a perpendicular bisector. Here's my knife, my big samurai blade. Boom! Perpendicular bisector?
Yeah.
Is it perpendicular?
No.
Perpendicular bisector.
No.
It's perpendicular.
It's not going through.
It's not going through the center. Right about like that. How about that?
Mm-hmm.
There we go. That's a perpendicular bisector. It comes down through the center. Boom. It's perpendicular. And it makes two segments that are equal. Perpendicular bisector.
Sounds like bystander.
Ooh, a perpendicular bystander. Yep. Perpendicular bystander is somebody that's watching something and just standing just like this. They're perpendicular. You smiled at that one. Right? Oh, okay, that's good. Huh? It's a good jerk. Good jerk. Good jerk.
I'm a jerk?
No, good joke.
Oh.
All right. Keep your notes available. Get out the whiteboard and a marker. Way to go. Aiden. Way to go.
I got you one.
I am. I'm giving you encouragement, Aiden.
Now you can never.
Whoa, Presley! Okay, ready? Name that sport.
See you later, raccoons.
Cricket. Name that sport.
Actually, there wasn't really
Softball. You're lame at this game. You're not good at this game at all. Okay. Water polo. Hockey. He's good at this. Water polo is right.
How is that one?
Water polo is fun.
Dude, go to the
Oh, you thought? See, no. Lacrosse.
Polo. Cricket.
Cricket. All right. On your whiteboard, tell me what's going on. You have either perpendicular bisector, angle bisector, altitude, or median. These are your options.
Wait, can we abbreviate?
Sure. We're looking at IK. What is IK? Tell me what IK is. That is correct. Good. What is IK? Good. Good.
Oh, shoot.
I shortened it.
Oh, you shortened it. Got it?
Oh, my God.
Good, 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 good. Remember, altitudes have to be perpendicular. This is a median. It's cutting that guy in half.
I'm just gonna put the first
This guy right here, what is this one? So you're saying it's an altitude?
Yeah, I would say 80.
It's not an altitude. And you gotta give me more than that because this is angle bisector and I'm not sure which one you're telling me.
No.
Good. Perfect.
I
Yes.
didn't want to write the entire thing.
Good. 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 It is an angle bisector. Notice it's cutting this guy directly in half. Next one. What are we talking about? We are talking about P and R. P and R. And it also says, we're talking about this. Oh, that was the right color to use. Green on green. Okay. Talking about this. And it is a right angle like that. PRS. So what is PR? PR is, I'm thinking about it. Got it. Good, 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 good. You're gonna be good. That's good. It is an altitude.
Huh?
Ooh. This time we are talking about TV. So we're looking at this one right here. And it says that STV is a right angle. A right angle. What does a right angle? Oh, this is that one. Oh, and TU is ST. And these guys are congruent. So what is going on there? I know what it is. It's not an altitude. Altitudes come down from a vertex, not an altitude. Medians, medians come down from a vertex. Is that coming down from a vertex? That is correct.
Yay.
Not a median. Medians come down from a vertex, not coming down from a vertex.
I agree.
Perpendicular and it's cutting something in half. It's perpendicular and it's bisecting something.
Dude, I wonder what it is. It's like
It is a perpendicular bisector.
perp by
Notice it's coming down, it's perpendicular, and it's bisecting. Looking at this one, we're talking about ZX, or XZ, this guy right there. Chris says that's easy. An altitude would come down perpendicular. We don't know if that's perpendicular. A median breaks this in half. We don't know if that's broken in half. A median, I don't know if those are the same. An angle bisector, this is 40 and that's 43. It's not an angle bisector. An altitude, I'd have to know if that's perpendicular.
Perpendicular, Mr. Barre.
What are you saying?
Nothing.
Nothing is correct.
Yeah.
A median would have to cut this guy in half, and I don't know if
And
it's
see, it's 43 and 40.
an angle bisector. There'd have to be like 40, 40.
Yeah.
Oh, I got it.
Nothing. I was right.
What's it cutting?
No, you didn't.
One's 43 degrees, one's 40.
We talking about the angle or the segment here?
No.
You know that those are the same?
Oh, I'm pretty sure.
Based off of what?
Look the same.
Oh, they look the
I'm
same.
sure that rocket's gonna make it to the moon.
Yeah.
That'd be accurate. Well, I would have tested.
Do you know your stuff?
I'm pretty sure.
All right, this one.
Just in case, Donald.
We're talking about woo.
Woo. Oh, like from Chicago?
No, like Mushu.
Tell me about woo. Woo.
Uh-oh.
Angle bisector? I don't know if it's cutting that in half.
There we go.
Altitude? This is perpendicular when it comes down?
That looks strange. Oh, I got this.
It is perfect.
Median, this split it right in half?
Guys.
66 and 84?
Guys.
Altitude? You're saying this comes down and it's perpendicular.
Altitude doesn't have to be perfect.
Hey.
Altitude doesn't have to. What about my airplane picture?
Well, altitude, it just has to come straight
Good,
down.
good.
Oh,
This
I'm
is a
good.
nothing.
Yeah.
This is a nothing. Don't be sad.
I'm not sad. I'm happy.
Okay.
That's how you say Jordan.
I wish I
I hear my name a lot.
Get your notes back out and turn to the next blank page and give me 4 boxes.
Mr. Barre, you're killing me.
We are doing congruent triangles now. Man.
could. Guess the sport.
Ooh.
Garage.
It was bowling. Good job, man. Actually, you know that new Mulan movie coming out? With moves like that? There's this one scene. They're like, it's just just like this.
Wait, they didn't put the dragon.
I want to see that movie though. I think it looks good. All right.
It's just like.
Boy.
She was the best player.
They want to hear
I went to life.
Come back in. Last unit, we took 2 triangles and we moved them on top of each other to show that they are congruent. The thing is, we can show they are congruent with other ways, and that's what we're going to look at right now. We have 4 different ways that we're going to learn about for showing congruency, and here they are. The first one is called side, side, side. If every side of this triangle has the exact same length as every side of this triangle, they are the same triangle. If I gave you 3 sticks and all the sticks were, you with me? I had a long one, a medium one, and a short one. They're only there's only one triangle that could even be made using those sticks. And so these two would be congruent triangles. So in our notes, this is called side, side, side. SSS.
So those weird letters for,
Yep.
Side repeating.
yeah.
I was like super sufficient.
I just.
So if I have a triangle and another triangle, if those two sides are the same length, and these two sides are the same length, and this one is congruent to that one, those two triangles must be the same triangle.
That's what that is. This one is, so the bottom one is 1 and then the top one is 2.
Got it. So rotate this one.
What?
No, I
think
no,
it's a
they
mistake.
are. It doesn't matter the orientation. Okay, I think I see what you're doing. Let me just draw another picture. That's our official note picture.
Yeah, because like on this one, the short line only has 1 line in it.
Oh,
and
yeah.
The other short line on the other side is 2.
TU and
No,
CA.
so ready? Here's a triangle. You cool? We're good so far? Okay. I say that these two guys are the same side. I realize they're oriented differently. Cool? Those two triangles, I know for a fact, are congruent triangles.
I understand that. I don't think you're getting what I'm saying.
I'm not getting what you're
I think
saying.
it's a mistake. T to U has 1 dot in it, right? 1 slash in it? T to U?
And that'd be the one that's
On the right.
CA.
It's
They mix them up. I see what you mean, Chris. TU and CA,
Are supposed
there
to be
would be the
congruent.
one that would be matching, but they don't have the same amount of sticks on it.
It's AB that has the one, but it's
No, I don't see what you're saying. The fact that these three sides are congruent to those three sides proves that these
It's
two
because the
triangles.
way the slide, it's
Yeah, I know.
It's because the way his slide is that it looks different than ours. Or than but it's
Okay,
it
so
is
side
different.
TU only has 1 stick, and then side CA on the other triangle has 2 sticks, and he's saying that they're
If
the
you
same.
rotate
If
it.
you were to
Those are the
rotate them to
same
match
size.
up,
Yeah.
TU and CA would match up. That's what you're
Oh, is that what we're doing? How about a reflection?
Exactly.
Yeah.
It's still in the
Dude, yeah. Yeah.
Again, it's the way his computer is.
Okay, it might be skewed, but I can see the line up here. I see what you're saying. You're saying, hey, I can't rotate it. A rotation's not going to make it happen. Well, if I do it with a reflection, then. Okay. Now let's just. I'm hoping that I haven't skewed it with.
JJ, it just looks different because of the way his computer is.
No, I can understand.
I get what you're saying. Now sometimes. So you want that 3 has to match up with the 3. And the 2 has to match up with the 2. I'm going to put it on the back side also. I'm not getting it then.
Chris, look on your computer. It's and that's what's
It's
up.
the way
Yeah,
that
it's
his
his
computer
computer.
is. That's all it is.
You got a little
Like the
scheme
same.
off on us.
3, 2, 1.
It's just the way his computer
It's just okay. 3, 2, 1. It's just that my computer, I skewed it or something. I get it.
If you look at
Or
yours,
if you can see it.
Does yours look better?
Yeah.
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 So it's just my projector doesn't project it perfectly. It either stretches it in one direction or the other a little bit. But it does with a rotation.
So sides CA and AB are the same. Like,
CA
and AB are the same.
and
one.
Wait.
no, CA is congruent to ST.
And then TU is.
Yeah.
Yeah.
The 2 hashes
They're the
mean
same.
those 2 sides are the same length. This is the same length as that. That's
Look
the
at your
same.
computer. Don't look at his because his is warped, so it's gonna make it seem longer.
Yeah. I was-
Chris, you're just
And-
confusing
I get
everybody
it, no, I
more.
get it.
Okay. And really, you don't even have to look at, don't focus on the images, focus on the hash marks. The fact that all three sides of this one are congruent to all three sides of that one proves that they are the same triangle. I realize my projector is projecting it weird. All right. Good. It looks better on yours?
Yeah.
It does, yeah.
It does look better. I feel like mine squished it in like this a little
Yeah,
bit.
because yours, it squishes it in.
It does squish it in.
Well,
Okay.
well,
All right. So this is called side, side, side. Excellent. Our next one is side, angle, side, I think. SAS?
Yeah.
Do they have a lot of stats?
So this one's called side, angle, side. So side, angle, side, SAS. Or, there we go.
You spelled my name wrong.
What's your name? Is there a Y in it?
Yeah.
Jordani? Is that where you put the Y? Where's the Y?
There is no A.
I apologize. I know. Okay, it's called SAS. So this is what it looks like. I have a triangle, and I can orient them differently. So boom, and a triangle. I'm kind of doing a little bit of a reflection. So if I have a side, angle, side, side, angle, side, side, angle, side, side, angle, side, 3. I know they don't look, hey Chris, I know these two don't look congruent, but the way I've marked them up proves that they are congruent. Cool? So yes, I know,
No, I just.
yes.
Would it matter if the angle is in a different corner?
It would, well then I'd have to also move this, so if I did, side, angle, side, side, angle, side. 1, 2, 3, 1, 2, 3. Those guys are still congruent, according to the way I've marked up the drawings. Side, angle, side. Our next one is asada, like carne asada,
I
ASA.
love it.
You do love it.
I love
Angle,
Yes, baby.
side, angle.
The next one is AA.
Whoa, not
Oh, no, look at the wrong one.
Angle, side, angle, angle, side, angle.
Wait, so is there there's a side angle, but there's not oh, wait.
There's not a side angle. I know.
There's an angle side.
So our
but there's
last
not
one
a
is, yes, so
Angle side.
there is angle, angle, side.
Is there no angle side?
There is not. What would that spell? And that's why it doesn't exist.
Oh, I was thinking because there's an there's a side, there's an angle side, so I was thinking.
But there's not.
It's
So,
angle side, but they switch it up, put side, angle side.
Oh, that
No.
makes sense to me. I was
no,
thinking-
it's not switched up and become it doesn't exist. Angle side doesn't exist. And you can't just switch it up.
That'd be basically what
No, that
The-
the only
yes.
reason I was asking that is because it's angle side.
So let's
I
do
was
it.
thinking-
Let's draw the picture for this one.
Yeah.
Angle, angle, side, angle, angle, side.
I keep turning the rectangles.
ASS or SSA doesn't exist. All right, I'm going to write it. I know you're going to be upset. I know I'm going to get fired over this, okay? These two. I'm going to, okay, SSA or ASS do not exist.
Don't laugh, it's not funny.
Okay.
Wait, but why doesn't it?
Okay, I'll show you a YouTube video. Why?
Oh no.
Why are you just gonna go into it more time?
Exactly.
What?
Basically, it's this content.
But this calls for fighting. I love how they put a picture of a doggy.
Alright.
Like look.
Wait, there's four.
No, it's 3. There's 3.
So now that we've covered the 5 triangle congruence theorems, you may be asking, what about angle side side? Please don't be uptight. Okay, so now let's go ahead and explore why angle side side would not work as a triangle congruence theorem. So if we have a set of corresponding angles that are congruent and a set of corresponding sides that are congruent. Okay, so we have 2 sets. We have an angle followed by 2 consecutive congruent sides. The issue is with that second congruent side, since we don't know the angle in between the 2 congruent sides, we don't exactly know its position. So I can take that side and swing it over to a new location and still show that angle side side is still the case here, no matter how I choose to draw that second triangle. And I have the option of drawing it either way, since that's an isosceles triangle, so both of those sides are definitely congruent to each other. Now if I draw it this way as an acute triangle, I see that I have angle side side. However, the base of each triangle clearly are not the same, and these triangles clearly are not congruent.
It's more about
So due to this ambiguity, angle side side or side side angle is not enough to prove that 2 triangles.
Okay, so right here, I can see that I have the same angle, the same side, and the same side, but those are not congruent. Now, if this guy swings out, as you saw, then they would be congruent, but it can't have it both ways. It's either congruent or it's not congruent.
big brain.
So that's why angle side side doesn't exist. All right, I've put up the ones you need to know for today, these 4. Let's do a couple examples with whiteboards.
Wait, clap on.
All right, so looking right here, what do you say? Is this ASA, SSS? What is this one?
Ooh, I know what it is.
Whiteboard. I do have to turn like that.
No, we please.
I can't see you guys. Good, 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 good. Good. It is SAS. This one. Perfect, perfect. Beautiful, beautiful. Excellent, excellent. Good. Good, good, good. This is side, side, side. This one.
Wait a minute.
It is a thing.
Angle, side, angle. Now, when I'm saying You're gonna have to actually show which ones, how they're congruent. Here's how I do it. I like to start at the one with the single hash. So ready? This would be Q, S, R. See how I'm tracing over the hashes? Where would I start over here then? H, J, I. So that's how they're congruent. Q, S, R goes with H, J, I. Or I can do it in a different order. Let's start with R. R, do you want me to go to the single or to the double? Okay, R, double single. I, double single. Because I have to get the letters to match up correctly. We saw that when we were doing transformations. The letters must match up. I can start somewhere else too. Let's do double, double, nothing single. Double, nothing single. I'm tracing over it. Let's do one more. Have another one here?
That's it.
Good, this is angle, angle, side. Where do you want me to start? You want to start with the double, the single, or the nothing? Nothing? Okay, ready? Nothing, single, double. Nothing, single, double. That's the order I'd have to put the letters. There was no triple on this one. I can start here. Let's start with double. Double, nothing, single. Double, nothing, single. I just match up the letters. That way everything matches up. We're done. You got 3 XLs, 15 minutes each, or 80s. I think that's it.
What about 10 minutes?
I can go up to 20. Okay. 3 IXLs, 15 minutes each, or 80s. Yeah, I'm good. I think that's what I said. What's it say in the homework file?
It says 20 minutes.
The actual middle school homework Google class. Whatever that says.
So for the one that says only one, it says 20 or 100, and then for the
That's not what I'm
one,
looking
it
at.
says 10.
The middle school homework file.
Oh. Someone didn't say.
Yes. You may not yet. Can somebody look up the middle school homework file? Why does that force you to go in a specific order? Because angle U is congruent to angle D. So you've got to be in the same order.
Oh, so they can be in any order as long as they're.
No, they can't be in any order. Well, you can start at any with the same corresponding one,
They have to be the same.
but then it's got to be in the same sequence.
10 minutes each or 80.
10 minutes each or 80. There we go. 10 minutes each or 80. 10 minutes each or 80. Chris, you got that? 10 minutes each or 80.